Hello, everyone, and welcome to our webinar on securing mobile applications with RASP technology. Today, we'll give you a short introduction on how today mobile threats are changing digital landscape and explain to you why security of mobile application more critical than ever. We will also show you how you can easily integrate RASP SDK into your mobile application and detect whether your app is being installed on rooted or jailbreak device. Applications that are run on such devices can compromise the main functionality of your app. Statistics about security in the mobile app are always amazing, but not in a good way. When it comes to security and securing mobile apps, most of mobile app developers relies on server-side and data storage, which cause that more 50% of the apps include security flaw. 82% of Android apps have at least one of 25 vulnerabilities. One or four apps contains at least one high security risk, and even 75% of the all apps would fail basic security tests. In this section, we will delve into the various types of threats that mobile device encounter in today's digital age. We will mention a couple of them, which are the most common and the most important. First of all, there is a malware. Malware is malicious software designed to compromise mobile devices. This includes viruses, trojans, ransomware, and spyware, which can target sensitive data, financial information, and device functionality. Second one, we have data breaches. Unauthorized access to sensitive information stored on the mobile device or transmitted over network can cause data breach. Data breach can result in identity theft, financial fraud, and reputational damage to individuals and to businesses as well. Then we have network attacks. Network attacks, such as man-in-the-middle attacks, can intercept and manipulate network communication. Attackers can eavesdrop on sensitive data, or they can inject malicious content into communication channel. These days are very, very famous phishing and social engineering attacks, where attackers often masquerade themselves as legitimate messages or requests from trusted sources, and they are tricking users into providing sensitive information. And the last one is unauthorized access to device features. Exploitation of these vulnerabilities to access device features such as camera, microphone location, and contacts can lead to various attacks. Attacker may also use this access for data collection or some tracking. It's also important to note that the mobile threat landscape can also vary by geographical region. Factors such as cybersecurity maturity, mobile adaptation rates, and regulatory environment influence this threat level. The mobile threat landscape is also constantly evolving, with attackers developing more sophisticated malware and social engineering tactics. And there's a trend towards targeting specific industries, user demographics, or geographic location, emphasizing the need for adaptive security measures. Seeing all this, there is a huge also impact on the mobile threats. First of all, there is a financial losses. This is one of the most common impact of the mobile threats. So mobile threat can lead to direct financial theft through unauthorized transactions or ransom demands. And additionally, business may face the indirect costs related to incident response, forensic investigation, and legal fees. Second one, there is a data privacy breach. Compromising sensitive personal and corporate data can result in violations of privacy regulation and loss of user trust. The third one is reputational damage. Mobile threats can cause negative publicity and damage to brand reputation, resulting in a loss of customer confidence and market credibility. And fourth one is disruption of business operation. Downtime and productivity losses due to malware infections or data breach can disrupt business operations and damage customer relationship. I will now show you one example, actually the case study. It's example of WhatsApp Pegasus spyware attack. So in May 2019, it was discovered that a vulnerability in the WhatsApp messaging app was exploited to install spyware called Pegasus on user devices. The spyware was developed by one company, NSO Group, and this could it could be installed on the devices simply by placing a WhatsApp call to the target device, and then if the call even if the call was not answered. So once installed, Pegasus could gain full access to the device data, including messages, calls, emails, photos, and also location information. And it could also activate the device microphone and camera for surveillance purposes. What was the impact? There was a huge impact on the users because individuals using WhatsApp, including journalists, activists, lawyers, and human rights defenders, were targeted by this spyware. Their private communication and personal data were compromised, and this was leading to big risk. Also, it was a big risk for businesses because the incident raised concerns about security and privacy of messaging apps used for business communication. And companies relying on WhatsApp for internal communication may have been at risk of unauthorized surveillance and data breaches. This led to a big impact to overall mobile ecosystem because the WhatsApp Pegasus spyware attack highlighted the vulnerability of popular messaging apps to sophisticated surveillance techniques. And it understood the need for stronger security measures and regular updates to protect against such threats in the mobile ecosystem. This leads to us why mobile application security matters. There are four things to highlight here. First one is importance of securing mobile applications. So in today's digital economy, securing mobile application is a must. Mobile devices have become integral to our daily lives, serving primarily as a primary means of communication, access to information, and conducting transactions. So we are using mobile devices on our everyday task. Second one is increasing reliance on mobile devices. There is an increasing reliance on mobile devices for everyday tasks, and users depend on mobile devices for banking, for shopping, for communication, and work-related activities. Third one is implications of security breach. Security breaches can have huge consequences, and they may result in financial losses, damage to reputation, legal consequences for individual, but also for the businesses. And I would say the most important is importance of user trust. Earning and maintaining the user trust is crucial, and secure mobile applications are essential for preserving user trust and confidence in today's digital ecosystem. So having all of this in mind, we have one of the solutions and technologies that can help overcome these threats, vulnerabilities, and reduce consequences. And this is RASP. RASP stands for Runtime Application Self-Protection Solution. It can be implemented as an SDK, which is integrated directly into mobile application. And this ensures application is protecting itself from security threats in the real time. Controls that RASP is using are activated during application runtime, making sure that all the threats are detected right away while user is using the app. Some main benefits of the RASP is definitely real-time statistics. With RASP, with an SDK, there is a dashboard available that provides insight into attackers, users, or mobile apps. Also, client can decide how he can configure apps to react, what will be the app's behavior, and what will happen when attack is detected. Also, there is a report that is available on the dashboard, and a client can export all the data as stats in the Excel or CSV file as well. RASP is offering real-time detection. It detects real-time threats and actions, like if the mobile device is if the mobile application is being used on jailbreak or rooted device, if there is a usage of emulator or debugging, if there is any hooking on screen recording on iOS. Also, RASP provides proactive protection, meaning when RASP detects attack, it detects it in real time. And after he detects something is happening, he can terminate the app or notify end users. Now we will present you the developer showcase, and actually we will explain you how to integrate jailbreak detection into iOS apps. So I will now leave the mic to my colleague Carolina, and she will shortly introduce you to this showcase. Carolina, you can continue.
Hello, everyone. My name is Carolina, and I'll be discussing how to integrate our App Protector freemium framework into an iOS app using Xcode. We'll also cover how this framework works and explore some strategies to bypass jailbreak detection using tools like Frida and some further steps on how to mitigate these threats. So let's get started. First, as we already said, threat detection is important since jailbroken devices pose security risks. They can allow unauthorized access to system files, enable malware, and lead to data theft. So that's why we developers should protect our app integrity and user data from potential threats. We have developed a light framework, our App Protector Freemium SDK, which offers a limited threat detection, such as jailbreaking detection, code signature, and check if the app is downloaded from a trusted source verification. Supported reactions are to these threats is notifying the user, but as we said in our full app detector, we also have kill reaction or present false values to the user so that the real values are protected. So now let's get started on how to add the framework to the Xcode project. It's similar to any other framework. So we added by selecting the framework. We should make sure that copy items, if needed, is selected and that we choose the appropriate target to which we will add the framework. Next step, we should go to the target, general, and scroll down to framework, libraries, and embedded content, and see if our framework is embedded and signed, so that when the app is installed, the framework is included in the app and signed by our profile. Okay, so how does this framework work? This framework detects jailbreak by checking the file system for certain names such as Syria or mobile substrate. These are jailbreak specific strings. And it also checks for system API calls or for sandbox violations. It checks if there are attempts to access or modify files that should be restricted. The framework also checks for code signature if the app is signed by a proper distribution profile. And it also checks for the source from which the app is downloaded, if it's installed from the App Store, which is a trusted source. Here we have an example of an app we have developed. It's a demo app which showcases this framework. We check if the app has certain risks. To use the framework, we have exposed the class called RASP facade. It has one method, do detect on demand. It accepts RASP configuration. It's an array that accepts which threads we want the framework to check. So we would add to the array jailbreak, code signature, or trusted source. And then the method will return array of all the detected tamperings. This array is an array of enums which have a raw value, and we can see that we have here a device that is jailbroken. The app doesn't contain official code signature, and it's installed via untrusted source. So we know that it's not from the App Store. So this is a basic protection for the app, which can be bypassed with a tool such as Frida by hooking to jailbreak methods to showcase that there are no CDF files on the phone or similar, and it can change other values. So we should update these frameworks to have the latest detection methods, such as detection for Frida, for hooking methods. We should also check if the screen is being recorded so that when a user is entering its PIN, it's not recorded for an attacker to see. And these multiple detections make a stronger defense against these tools, but it's still not enough. We also recommend to obfuscate the code so that static analysis is much harder. An attacker could disassemble the app using a tool such as Hopper, which then allows for the attacker to see all the methods and classes inside the app, which then he can hook with Frida. If we obfuscate the strings and the methods and classes, it's harder for him to analyze the app. With this Hopper tool, the attacker could also change the app and change its integrity. So we also recommend checking for apps integrity, if it's properly signed, if it hasn't been tampered with. And we also recommend monitoring for unusual activity, for example, with our RASP portal, which in real time showcases users uh, that have threats that might expose their sensitive data. Thank you for your attention. And now Željka can continue to explain more about our solutions.
Thank you, Carolina. I will continue then. Okay. So Carolina presented how to use the basic RASP functionality. I will now go much deeper into what we can offer more from App Protector. So I will present here the layers of app security. So in the first layer, we have App Protector, which is creating reactions for mobile app attacks. So this is something that we presented as RASP functionality, but if you want to secure your application even more, we always recommend to build the security even more with additional layers. Layer 2 is integrity check, which prevents tampering of the release mobile application. And the strongest layer of security is called obfuscation, which is creating source code difficult to understand and making harder for attackers to do reverse engineering. App Protector is actually RASP SDK. It is based on the RASP technology, and it can detect jailbreaking, debugging, rooting, emulators, hook, screen recording for iOS. It can react on these detections by notifying the server, by notifying the end user, by terminating the app, or generate false values for example, logging into internet or mobile banking. Also, all of this that I mentioned can be analyzed on the dashboard, where you can get detailed reports and analysis on how many attacks we detected, how many users has been affected, and so on. Regarding the dashboard, so what we offer in the dashboard is responses that we send to end customer. This is notification where we telling the customer, the end user, that something has been detected in the app. Also, we can terminate the app right away when we detect the problem. For the owner of the app, this dashboard that is represented on the left side is admin web portal, where the owner of the app can see the time peaks of the attack, how many attacks we detected on Android, on iOS, and so on. We can also integrate through our APIs to a different systems, and we provide here a configuration setup, meaning that you can configure how your app will behave when we detect some attack. Some of the features that we provide within the dashboard is a management dashboard. Owner of the app can create configuration per app or per user, so he can decide, for example, for some user that is very important to me, if we detect some attack, please don't terminate the app, just notify him. We also provide number of attack in real time per user and per platform, and all of these reports can be exported into Excel or CSV file. And there is an audit log, which can also display everything that owners of the app are doing in the dashboard. We offer this solution as offline and online component. In offline, we provide only SDK, so detections and reactions here in the SDK are hard coded. If you want to change the configuration, you are doing that through the SDK, and then you have to update the application once in a while. But with the online, with the presence of the portal, then you do everything on the portal. It's a very easy and it's very simple, and there is also ability to make on-the-fly configurations which are effective immediately. So once you change something, it is right away effective on the app and on the users. Also, we provide these solutions in our hosting center. There are other app security components we provide beside RASP and its portal. This is integrity check. So integrity check is protecting the original code from tampering, and it makes sure that your code hasn't been alerted since the last official update. Why is integrity check important? First of all, because of the user trust. Users are more likely to trust and continue using an application that demonstrates a commitment to maintaining its integrity. Also, maintaining app integrity helps protect user privacy and prevents data leaks, which is very important for the data security. It is very important that functionality and performance of the app are not compromised. An application with a high integrity is less likely to have some unexpected errors, crashes, or some other problems. Also, brand reputation is also very important, because building and maintaining app integrity is essential for creating a positive image, and it's very important for user loyalty. And the last one, by prioritizing this app integrity, developers can ensure compliance with relevant laws and regulations, maintaining the integrity of the app. How do we do this, and how does it work? So after the final app build and before publishing to the Google Play or App Store, we calculate the fingerprint. So when we calculate the fingerprint, we store this inside the code, after which the app is repackaged and then published on the Google Play, on App Store or App Store. And every time when the user starts the application, the fingerprint process is repeated, and the new value is compared to the original value that is stored inside the code. And then, depending on the outcome, application access is adjusted. So When we detected that this is the same, that the fingerprints are matching, then integrity of the app is okay. But in all other cases, the integrity of the app is compromised. And the last layer of the security we will present, it's a code obfuscation. This is one of the most sophisticated methods to secure your original source code and to protect intellectual property of your application. Also, it's very, very good for prevent reverse engineering attempts. What is it? It is obfuscation is making source code difficult to read. So the process may modify actual method or instructions, but it will not change the functionalities and features of the apps. We protect strings and codes in both Android and iOS platform. Obfuscation is covering three main domains: strings, where we obfuscate licenses, URLs, ciphers, API keys; the code obfuscation, where we obfuscate class and variable names, but also the function names; and our newest feature that we introduced, it's control flow obfuscation, which is in testing phase right now, but we started with the dead code injection for this particular feature. Okay, so to conclude what we shared today with you, we gave you insight into mobile threats and what are their consequences and why it's very important to secure your mobile apps. Also, we represented the RASP technology and its solution, and we'll show you the showcase how to integrate an SDK into mobile app. And on the last, we presented you also with other security layers and the mechanisms how to protect your application even more. That was all from us. Thank you for your time, and hopefully this webinar is helping. Goodbye.